Alright, good morning. This is Suzanne Bird with the Ute Lake Online Learning Center. Today's video is Algebra 1, Semester 1, Unit 2, Lesson 5, which is solving equations by adding and subtracting, also known as one-step equations. Alrighty. So let's get started. Okay, here is a one-step equation, a simple equation that means that you only have to do one thing to solve it. A lot of these equations you could actually solve in your head, all right? Some of you are good with math in your head and you already know what plus 4 would give you 12, and you already know what x is. And there's nothing wrong with that. I applaud the mental math. I'm going to show you the steps of doing this though, because the steps of doing this are very important for later on when things are a little bit more complicated. Okay? When we do math normally, like think of elementary school math, you learn all about adding and subtracting and multiplying and dividing and fractions and all that good stuff. Okay, you learn the order of operations. Maybe you don't learn that until middle school, I can't remember. But order of operations says you're going to do stuff in parentheses, then you're going to take care of any exponents. Okay, then you're going to multiply and divide, and you're going to go left to right when you divide. Alright, and then the last thing that you usually do when you're solving a problem with the order of operations is you add and subtract. Okay, that's your normal order of operations. When you're solving an equation, when you're trying to figure out what this letter is, what number this letter represents, you need to isolate the variable. That's the terminology used. You isolate the variable by using basically the reverse order of operations. Okay? So, the reverse order of operations means that we would take care of any adding and subtracting first, then multiplying, dividing, and so on and so forth. Of course, when it gets up in here, things get a little bit different. It's kind of a combination, but we'll worry about that when we get to that point. Right now, we're just thinking about going in the reverse order of operations to isolate the variable to solve this equation. Okay? And not only do we do reverse order of operations, we do reverse mathematical operations. So you see this plus right here. Something is being added to x. To figure out what x is, to isolate him, I'm going to undo what is being done. Okay? I'm going to undo what is being done. So what is being done here is something is being added to x. So to undo, I'm going to do the opposite, which would mean I would subtract that same thing that is being added to that. I'm going to subtract that from itself. And so what happens when I do 4 minus 4? 4 minus 4 is 0. Okay, so that means that this side of the equation is really x plus 0 now. Now the whole thing about equations is that this side, the left side, equals the right side, always. If it doesn't, then it's not equal. Okay, so currently, right now, I have changed it and it is not equal. So in order to keep the equal sign true, whatever I do to one side, I have to do the exact same thing on the other side. All right, think of a teeter-totter, and you've got a kid on it. Right? There's a teeter-totter and a kid gets on, or a seesaw, whatever terminology you used to. A kid gets on it and the teeter-totter goes boom to the ground. Right? It's no fun until another kid comes and gets on it. Now, if this kid that gets on it is really light compared to this kid, then nothing really changes. Okay? But if the kid that gets on is basically similar in weight, then what happens is the teeter-totter, seesaw, equals out and they're even. Okay? And so then if another kid says, hey, I want to play, and he comes and gets on, right? Well, we know that the seesaw is going to go down like that with these two kids. And so then they call out to another buddy, hey dude, come jump on this with us, and it evens back out again. Okay? So that's essentially what we're doing with isolating the variable, solving algebraic equations, is we're playing on a seesaw or a teeter-totter. Okay? So right now, I've taken weight off of one side, so I have to take the same amount of weight off the other side, or it's no longer equal. Okay? So whatever I do to this side of the equal sign, I have to do the same thing to this side of the equal sign. Okay? So then we know that 12 minus 4 is 8. Okay, so we know that x equals 8. We could probably figure that out without doing these steps. But this is the steps of solving equations, so when they get more complicated, you follow the same exact steps. Okay? Now note, I wrote plus 0 down here. We don't normally write plus 0 because it's understood that anything added or subtracted to 0 is still the same thing. Okay? So writing plus 0 is redundant, it's extra work, and mathematicians are notoriously lazy. That's why they come up with all these crazy steps. And anyway, so instead of writing plus 0, we just cross out the thing that goes away. So 4 minus 4 becomes 0. It goes away. It's gone. And so instead of writing plus 0, we just cross this out to tell myself, okay, I got rid of that. Yeah, I put it over here. Cool. Then all I do is I drop down what's left on this side. The only thing that's left on this side is x, because everything else is 0. And then equals 8. And there is my solution. And you can always check by then plugging this number back into here. Well, 8 plus 4, does that equal 12? Yes, it does. Okay, so this is the right answer. I didn't make a mathematical error. Okay? So, let's look at another one where things are in a different place. So, here, it's the same thing, only the x and the number we're getting rid of are in different places. Okay? When it's a one-step, when it's a simple equation like this, I can look at this and say, okay, I know I'm going to subtract. Another way, when you've got numbers out here, when the x and the number is different, you also can think of the sign of this number. Okay, this number, since it doesn't have a negative in front of it, it's really positive, right? It's understood that this number is really positive. So you can think of that number as positive, also meaning that plus 15. Plus 15 is being added to x. So in order to undo the plus 15, I'm going to subtract 15. Okay? And the reason I'm telling you this now is because it gets a little hairy when this is a subtraction sign in here and they've got a number over here, which I'll show you. I'll give you examples here in a minute. So right here, okay, I've got to undo what's going on here. So a positive 15 is being added to x, so I'm going to subtract 15 from itself. I have to do the same thing to the other side of the equal sign to keep things level. Okay, this goes away and everything here drops down. Okay, so this is now saying this is a positive x, so I don't have to worry about signs or anything. I just drop that x down. I do this math. I can't remember what this is. What is that? 8. I don't want to make a mistake and then have to redo the video. You know, silly mistake. Boom. Okay. All right, now let's look at subtraction. Okay, here we go. We've got, and you can use different letters. Different letters are used. Here we go. Like, I mean, it doesn't always have to be X. I can call this A. Okay, so I'm looking here. A is being subtracted by 7, right? A take away 7. So the opposite of take away is adding. Okay, so if I add 7 to this right here, think of this as a negative 7 if I cover up the A and just look at the sign and the 7. So the opposite of negative 7 is positive 7. That's one way of looking at it, or looking at it adding 7. Okay, when I do this, it's going to be 0. I'm going to cross them out. Whatever I do on this side, I have to do the same exact thing to that side. Okay, the only guy that's left is the A. All right, voila. I can check. 20 minus 7 is that 13? Yes, check. Okay, let me just erase this. Okay, so here's one that will help illustrate what I was talking about earlier with the signs. Okay, here the number, the coefficient, it's not the coefficient, the constant is in front of the letter. Okay, if I go in and I look at this, this says I'm going to subtract. But if I just do this, and I do this either in my head or with a calculator if I'm not good with negatives, this is saying negative 7 minus 7. When that happens, negative 7 minus 7, this is negative 14. We don't want that. We want 0. Okay? So this is where this gets a little bit confusing. And so I always say look at the sign in front of the number you're trying to get rid of. Okay? The sign in front of the number I'm trying to get rid of is a negative. So what is opposite of a negative? A positive. Okay? So I'm going to add 7 here. And if I do this in my calculator or in my head, a negative 7 plus a 7 gives me 0. Okay? And I'm going to do the same thing to this side. Add a 7 to this side. Okay? So the only thing that's left on this side is the m. And then I do the math. 15. Voila. Okay? Okay, the minus signs and the negatives give people the most fit. For the most part, when everything is positive, not a problem. Okay? As even if it was this one and it even equaled a negative, it's still, people don't make the mistake as much here. They know they're going to subtract 3, whether they look at that or whether they look at the sign. And if I subtract 3, subtract 3. The only difference is here, I've got negatives going on, and that's okay. 8, 9, 10, 11. Voila. Okay. All right. So I think that's a good introduction. Now let's look at some of the problems that they give you in your lesson. They kind of skip over those simple ones like that and jump into these others that look a little bit more scary. So I want to look at one of them. One of them looks like this. Okay. Whoops. Not like that. Like that. Okay. What they're doing is the same thing, but they're adding another step. So this really isn't a one-step equation. There's 2 steps involved. Okay? Whenever you're trying to isolate the variable, all the variables need to be on the same side of the equal sign. Okay? So in order to get the variables on the same side of the equal sign, I'm going to do the same thing I was doing. I'm going to do reverse order of operations. And typically, if you struggle with math, I tell my students, always move your variables to the left. Okay, now that's not always good advice because you end up with some negatives sometimes, but whatever. But if you struggle with math, it's easier for you, it's more comfortable for you to always do the same thing over and over again. And so I tell my students, just move your variables always to the left. Once you get a little bit more comfortable, you can kind of look at it and decide which way to move the variables, which side to move the variables, to get rid of negatives, because we don't like dealing with negatives. Okay? But we'll talk about that here in a minute. All right, before I can do anything and figure out what x is, I've got to move anything that has x's over to the left, like I just said. All right, so I've got this 2x right here. It's a positive, it's being added, and I want to move him over here. I can't just physically rewrite him, that would be great. I have to do math to move him. So I'm going to apply the same principle. I'm going to undo what's going on. What's going on here is this 2x is being added to the 16. Well, I want to get rid of the 2x on this side, so I'm going to do opposites. Right? So opposite of addition is subtraction. So I'm going to subtract 2x. Okay? So just don't get hung up on the x's. Think about the 2. All right? 2 minus 2 is 0. Gone, right? So we cross that out. And then whatever I do over here, I'm going to do the same thing. Now then, it's important that you line up the guys that go together. All right? Guys with x's goes with guys with x's. Guys that don't have x's goes with guys that don't have x's. Okay? We want to keep the families. The Joneses go with the Joneses, and the Smiths go with the Smiths. We keep the families separate. They can they can barbecue together, but in the end of the day, they go home to their own houses. All right? So when we subtract the 2x, we're not going to subtract them from the 7 because we can't do that. We can't do that because we don't know what x is yet. So we have to subtract them from the x, the guys with the x's. So I'm going to line him up under the x's. Okay? Okay. What this is basically saying is that there are 3 x's. All right? If you have an apple and another apple and another apple, right? I can see that there's 3 apples. I can add them all together and go, voila, there's 3 apples. Okay? Another way of adding is multiplying. 3 times 1 apple is 3 apples. Okay? So that's all that's saying. All that is saying is that there's 3 x's here. This is saying that there's 2 x's here, and I'm subtracting. So if I've got 3 minus 2, I'm now left with 1x. Okay? And usually we write 1x by itself with no number by it. The number likes to be invisible. We all know, hey, I know that you're there, but I'm going to be invisible because it's just easier. It doesn't complicate things in my mind. All right, so 3x's minus 2x's is just 1x. Okay? We haven't done anything with the plus 7, so we're just going to rewrite the plus 7. All right? We haven't done anything with 16. We're just going to rewrite the 16. This was gone, so there's no reason to write it. Now, this looks like the ones that I've just did a while ago. Okay? So now I know that I've got to undo the 7, undo the adding of 7 to move him over here. Okay? So adding 7, I'm going to subtract 7 to make him go away. Whatever I do on one side, I have to do on the other. This guy cancels out because it's 0. X is left here. And then 16 minus 7 is 9. Okay? Now, if I plugged, I'm not going to do that here because I'm already boring you, I'm sure. If I plugged the 9 into the original equation and I solved it, both sides of the equation should equal. Okay? And maybe I should do that to prove it. Okay? So what I would do is that wherever there's an x, I would replace with the 9. Okay? So 3x, that really means 3 times x. Well, if x is 9 plus 7, that should equal 16 plus 2 times 9. Okay? So here we've got, what is that, 27 plus 7 is going to equal 16 plus 18. So the $64 million question is, do those sides equal? Okay? So it's 27 plus 7 is 34. And 16 plus 18 also is 34. Just double checking, make sure I didn't make a math error. Alright, and since both sides equal, we know that this is right. Okay, so that's a way of checking it. So if you're ever asked to check it or show how you check it, that's how you would check it. Alright. Okay, let's look at another one that they give you. With some negatives going on. Gotta love those negatives. Alright. So negative 8x minus 3 equals 13 minus 9x. All right, again, in order to figure out what x is, in order to solve the equation, we have to get all of their variables on one side, okay? And then we do that by doing the same thing. We undo what's going on in the original equation. We undo it by doing opposites, okay? And like I said, I highly recommend here at the beginning to move everything to the left. X's, that is, move all your X's to the left. That way you know you're going to do the same steps every time, and it helps you feel more comfortable. Okay? So I have to, before I do anything, I have to get my X's together. We got to have a family reunion, and the family reunion takes place over here on the left side. Okay? So I got to look at this 9x. It's being subtracted. So the opposite of subtraction is addition. So I'm going to add 9x to itself. All right? That makes it go to 0, right? I can look at this as just numbers. Negative 9 plus 9. Okay? If you don't believe me, plug it in your calculator. All right? Negative 9 plus 9 is 0. So that means that this goes away. Whatever I do to this side of the equal signs, I have to do the same exact thing to this side. And remember, I got to line up, I got to line up my x's with my x's and my whatever. So I'm not going to put the 9x here under the 3 because this 3 doesn't have an x. So they don't go together. They don't match. I'm going to put this 9x under the 8x so that the x's line up. Okay, so I'm going to add 9x here. Okay, so again, this just means that there's negative 8x's, and this means that there's positive 9x's. So I ignore the x's and I just do negative 8 plus 9, which gives me 1. Okay, 1x. And then I drop everything down that I didn't mess with. Right? I drop all that stuff down. Oh, I guess I don't have to drop that. Oh yeah, okay, that's not an arrow, that's a plus. All right, and then it's back to the same stuff we were talking about. Okay, I have to isolate this variable by doing opposites. That's a subtracting of 3, so opposite of subtracting is adding. Whatever I do to this side, I do the same thing to this side. This goes away. All I'm left with is x, and here is, what is that, 16. And if I plug 16 back in here, it will equal, both sides will equal. Okay. Let's see, that one's not too bad. This one, I didn't do one like this, so it's no big deal. It just, I put everything's over on the left or on the right side. Okay. It doesn't really matter where your x's are, the steps are the same. Okay, I only have one x, it's right here. Stuff's being added to it, so I got to do opposites to get x by itself. Okay, if you're extremely uncomfortable with your x's or your variables being on the right side, you can always rewrite it. Okay, and this is just for, some people just like things to look the same every time, and I get that. So if you must, just rewrite it like this. But be careful when you're rewriting. If there's negatives, make sure the negatives go where they go. Okay, so you can, if you need to, if this is more comfortable, you can rewrite it where everything's the way you're used to seeing it. Okay, but you don't have to, because the steps are the same. All right. 1 is being added to x, so to get x by itself, to isolate x, I've got to undo that. So by undoing, I subtract 1. Over here, I would do the same thing, right? And that means that the ones cancel out. Boom, boom. Whatever I do on one side of the equation, I have to do the exact thing, same thing on the other. So I subtracted 1 here, I've got to subtract 1 here. Same thing if I wrote it like that. Okay. So 17 minus 1 is 16. Okay, same thing here. All right, and it doesn't matter. You can go backwards or forwards. 16 equals x, x equals 16, x equals 16, whatever. Voila. Okay, so hopefully that'll get you through the adding and subtracting of solving equations by adding and subtracting. And the next video will be multiplying and dividing. See you then.